Welcome to today's video. Today we are going to work on checking similarities between two phrases. With these similarities, we are going to also consider meanings. Okay, so if we have two sentences or two phrases, let's say sentence A, Andrew is a good boy, and Akosia is going to school. We have to determine whether these statements are the same or not. But from the onset, you can actually determine that they are not related in any ways. All right. So let me add a third. Say a good boy is Andrew. This is somehow similar to what we have at the top. So let me push that up. Good. Alright, so let's see how we are going to achieve this. So first off, we have to there are many ways of implementing this, okay, but what the strategy that we are going to adapt is using natural language processing, and we are going to use the BERT model to do the encoding and the embedding. Okay, so without wasting much time, let's start installing the packages that we will need for this. All right, so we will need two packages. One we would have to install. The second one is already on Google Colab, but in case you are using your own system or your own PC, you would have to install that. So the first one, we are going to install the sentence transformer. Okay, sentence transformers. Let me get this out. Okay, good. This will be taken from Hugging Face. So I'm going to run this. Let me take this out. I'm going to run this. Alright, so I already have this installed, but if this is your first time, you would actually see the logs indicating that it's installing. And so what we are going to do is we are going to import this transformers. So the next thing is for us to import, we'll be using a cosine similarity to do the similarity calculations. Okay, after we are done with the embeddings. Okay, so I'm going to do from sklearn. This is already installed with the Colab, but if you're doing it from your own system, you'd have to do your installation manually. Okay, this is scikit-learn. Okay, so from sklearn matrices pairwise. Okay, import cosine similarity. So let me paste the text that we already had and then name it maybe sentences. Okay, good. So first off, we are to import the model of choice. As I said, our model will be the BERT-based NLI means tokens. Okay, so this is what we are going to use to do the encoding to derive the embedding or the vector. Okay, so the next thing is for us to initialize the model. So I'm going to rename this to _model. All right, and have another model variable here which will actually hold the actual model. So we have sentence transformer, then we pass the model name to it. Okay, let me just, okay, good. The next thing is for us to encode the sentences, okay, or the phrases that we have into embeddings or a vector, okay. So we'll be using the encode function, and then we'll pass the sentences to it. All right, so what this does is it converts the sentences to numerical values, and also indicates the relation between each and every character or each and every token that we have in the phrases in relation to the other tokens that we have in the phrases. So let's print it and see what we have. All right, we can simply say embeddings here. Okay, so before, let me cut this and bring it on its own line, and good, so we won't have this installing again. And also let me move this to a new line. Okay, good. Delete that. No, let me bring this back. Good. So if you're running this for the first time, it will take some time to download this model. Okay. Alright, so it's done. Now let's encode it and then see what we have in the embeddings. Alright, so as I stated, this is a numerical vector. Okay, so what we are having here is representation of a relation. Okay, how close each and every token or each and every character is to the others. Okay, so we can, based on this, to derive the similarity. Okay, and we are going to use a cosine similarity here for that. So what we are going to do is we are going to compare this first statement, okay, to the others and see how similar these two are in relation to the first statement. So let's now get to the cosine similarity. Okay, and then so the first argument, we are going to check this as against the others. Okay, so this will be our base statement. We are going to pick the embeddings, the first item, and then we will now check it against whatever is left in the sentence, in the list. All right, so let's run this and see. There's an error. Oh, okay. Alright, so from these values we can see that the first statement, the second statement is very close to the first statement as compared to the third. Okay, based on the score that we have here. Alright, so now we are going to write a function that would base it on this to actually determine if the statements are similar or not. We're going to put all this in a function, okay, but the function would only expect two statements. Without wasting much time, I'm going to put all this, define is similar, and it takes A and B. Alright, so I'm going to push everything here and then get rid of this. I'll probably bring it somewhere here. Okay, now we have to decide on a threshold. I'm setting it to probably 0.7. So if any statement is above 0.7 after we've calculated the cosine similarity, then we will consider that as similar or not. Okay, I'm going to say threshold will be 0.7. okay, so over here we are going to return, I'm going to say result, and then if result is the first item in it is greater than the threshold. Okay, but before that, this is in a NumPy array, so we'd have to convert it to a list first. So we convert this whole thing to a list, and then since we are now passing two parameters here, we will get rid of this, but now we are going to put A and B. Alright, so let's run this again. Let's get rid of this, and let's change the threshold to 0.9 just to make sure that the two statements actually mean the same, and not just because their characters or their words are similar. So we are going to compare sentence A. The quick brown fox jumped over the lazy dog. And sentence B will be the brown fox jumped over the hardworking dog. I expect this to be false. So we are going to print the results that we have here is similar. Then we feed it with sentence A and sentence B. Let's run this and see the result. So it's false as expected, but let's check the score we had. So we got 0.86. Even though the statements are not the same, but we managed to get 0.86, meaning in some way they are similar, but in terms of meaning they don't actually have the same meaning. So that's the more reason you have to put a threshold somewhere around 0.9 to make sure that the two statements actually have the same meaning, and not just because they look similar. Okay, so let's set our threshold back and then run this again just to be sure it's working. Good. Thank you for watching this video. Be sure to click on the like button and subscribe to this channel. Bye.